This is the key for exam 2B, page 3 of the exam. On the question asking for the following pair, identify them as conformers, enantiomers, diastereomers, or isomers that have different formula. So, first of all, with this first pair, which I've copied directly here, the first thing I check is, do they have the same connectivity? So they have, the front carbon has a methyl, bromine, and hydrogen. The front carbon has a methyl, bromine, and hydrogen, same so far. Back carbon has a methyl, hydrogen, bromine, and the back carbon has a methyl, hydrogen, and bromine. So they're the same formula and the same connectivity. So that means they are not isomers. I have the same formula. So they must be either identical compounds, enantiomers, or diastereomers. The best way I find to do this is, in the way that this is set up, I am almost eclipsed. So I can think of these methyl groups as, here I have these two methyl groups, and they're both pointing in the same direction. This methyl group is pointing down. Okay, so I'm kind of like flipping this upside down in my head. If this methyl group is this one, then the bromine is coming out at me. And if this methyl group is coming down, when I compare what's on this back circle, then the bromine must be coming back. And so when I put them in this conformation where I'm looking at it from a different point of view, it would look like this. And look, bromines with this backbone look trans. So I'm going to do the same thing with this one and keep those carbons the same and look to see what the bromines look like. So on this one, if the bromines are both down, and here it is. So I'm really just kind of looking at this one just from this point of view. So this bromine here in the front carbon is down, going here. So compared to that, the bromine and hydrogen, this bromine is coming out at me. So that would be this bromine here. And then on this one, go in the back, I have the bromine coming down. And again, the bromine is coming out at me if I look at it from this perspective, from this way. And you can see here that these are definitely diastereomers. This one has them trans, this one has them cis. But I have to look at them with the same carbon background if I'm going to summarize those, because of course they can spin around. The other way to go about these is to figure out R and S, and then so for this one would be R and S, and this one would be 1, 2, 3, S and S, SS isomer, and this one would be RS isomer. So one of those is changed, so they must be diastereomers. I would do likewise on the other ones. I don't think the other questions on here are as difficult. So on this pair, I would look at those, and actually I went through and calculated R and S for both chiral centers there. And so I calculated here that both of these were S stereocenters, and both of these are both S stereocenters as well, making them the same compound. So the conformers are identical compounds. Likewise on this one, after checking that the atom connectivity is the same, so it's CH3 connected to a CH with an OH off of it, connected to a CH2, connected to a C with a methyl group and an isopropyl group off of it, which is the same in this molecule as well. Then I went through, and rather than trying to rotate things around in my brain, I just calculated or analyzed it to find out R and S, and got this one to be S and S, and these two to be R and R. And so because of that, since stereocenters are exactly the opposite, they must be enantiomers or mirror images of one another.